S and H circuits. Memory is like ROM, SRAM, DRAM. Then computer organization techniques like machine instructions, addressing mode, ALU, data path, control unit, and instruction pipelining. This mostly comes in the uh, microprocessor and microcontroller topic. Okay. So first, let me discuss previous year gate question. So in that question, first I will ask question regarding whether you can able to answer the. Um, I will give you the options and questions. Whether you can able to answer the. Whether if you are able to find the answer means able to get the answer means you can tell. Okay. Later on we will discuss that one. Okay. So first question is JK flip flop. So in JK flip flop, we have J is equal to Q bar. So this is your question, okay? So J is equal to Q bar and K is equal to 1, okay? So assume initially the flip flop is cleared, which means the output Q, okay? Q as your output is 0, okay? Q is equal to 0. Then after the 6 clock pulse, okay? What will be your output? Okay, so output initially output is 0. Okay, so after the 6 clock pulse you have to tell the sequence. So these are your options: A, B, C, and D. Can anyone able to find the answer for this question? So what is the functionality table of K map JK flip flop? 0 0 0 1 0 1 1 0 1 1. So this is Q and this is 0 1 and this is Q bar. Okay, so Q means present state. Okay, this is your present state and this is your next state. Okay, so suppose my input is 0 0 means J and K is 0 0 means next state value also it remains in the same value. Okay, if it is 1 1 means Q becomes Q bar. Okay, okay, now you tell if now Q is 0 and Q bar is 1. Okay, so what is the value of J and K? What is the value of J and K now? initially q is equal to 0. Okay, so after applying the first clock pulse, okay, first clock pulse, after applying the first clock pulse, j and k is 1 1. J and k, both the values 1 1. So now q becomes, this is the next state. Okay, next state becomes q bar. So this becomes 1. Okay, so if it is 1 in the second clock pulse, the second clock pulse, j and k becomes, j becomes 0, j becomes 0, and k becomes 1. So my output is going to 0, this state. Okay, so in the third clock pulse, the third clock pulse, both are 1. J and k is 1 1. So q becomes, q is equal to 1. Again, the fourth clock pulse, q bar is 0. So j is 0. So j and k is 0 1. So output is 0. Okay, this state and this state. Okay, during the fifth clock pulse, during the fifth clock pulse, j and k is 1. So q is equal to 1. So what's my answer? 0 1 0 1 0 1. So answer is D. Okay. Anyone is having doubt? Okay. Shall I go to the next problem? So for the ring counter, the propagation delay of each inverter is 100 picosecond. What is the fundamental frequency of the oscillator output? Okay. So option is 10 megahertz. Second one is 100 megahertz. Third one is 1 gigahertz. Fourth one is 2 gigahertz. Answer? Any answer? Okay, so first let me find what is a ring oscillator. Okay, so this is a even ring oscillator or odd ring oscillator. Suppose if number of inverters connected is odd means, okay, so suppose if my input is 0, output is 1 1 0 1 0 1. Okay, so after that this will repeated as 1 0 1 0 1 0. Okay, so totally it is taking instead of 5 clock cycles it is taking 10 clock cycles. Okay, if it is even number of inverters means, okay wow, even number of inverters means suppose like this, input is 0, output is 1 0. Okay, so these two are matching. Okay, so it is taking uh, only one clock cycle. Okay, but here it is taking 2 clock cycle. Okay, initially, so my fundamental frequency is, okay, 1 divided by 2 into totally I have 5 inverters, right? 1 2 3 4 5, 5 inverters. So for the 5 inverters, each inverter is producing 100 picosecond of delay. Okay, so that is into 100 into 10 power minus 12. So this becomes 1 divided by 10 power 4 into 10 power minus 12. Okay, so this is nothing but 1 divided by 10 power 8. So if it goes up, becomes 3. Sorry, it's 10 power 3. So 1 10 power 9, 9 hertz. So what is 10 power 9 hertz? 10 power 9 hertz is nothing but 1 gigahertz. Okay, so so totally I have 5 inverters. 5 into each inverter is producing a propagation delay of 100 picosecond. For 5 inverters, 500 picoseconds. And the fundamental frequency of this ring oscillator is nothing but 1 divided by T. F is equal to 1 divided by T for even number of inverters. And F is equal to 1 by T for odd number of inverters. Okay. The answer is 1 gigahertz. So any doubt? Shall I go to the next problem?
Okay.
Third problem. A ripple counter using positive edge triggered flip flop of the present state of Q2, Q1, Q0 is 0, 1, 1. Then what is the next state? Okay. So this is your diagram. These are your options. So what is T flip flop? The toggle flip flop, yeah. So toggle flip flop என்னது? If T is T and clock, okay. If t is 0 and clock is 1 means q of t plus 1 is q. Okay, if it is 1 and the clock is means present state oda inverse. Okay. If t is 1 and clock is 1 means the present state is get altered. Okay. So the present state என்ன இருக்கு? This is q of 0, q0, 1, q2. Initially, they have mentioned the present state as 0, 1, 1. Okay. So they are giving positive edge trigger flip flop. So clock is on. Okay. So clock on ஆயிடுச்சுன்னா என்ன மீன் பண்றோம்? Q0 becomes toggle ஆயிரும். Toggle means invert ஆயிரும்னு அர்த்தம். சரியா? So if it get inverted means Q0 goes to 0, right? So if it is 1, this is 0, this is 0, and this is 1, right? Initially, because this is q and this is q bar. Okay, so 0 will go here, right? So during that state, it will remain in the same state, right? 1. But is this a synchronous clock or a asynchronous clock? So what is synchronous clock means? If the clock is given to the flip flop at the same time, that is called as synchronous clock. If it is not so, then it is called as asynchronous clock. Okay. So here 0 is going to the T1 flip flop, so it will remain in the same state. Then for 1, for the Q1, this is Q1, and for Q2, this is 0 and this is 1, so Q2 remains in the same state. Okay. This is about static logic. Okay, static logic. So here they have given V2, V1, and two transistors connected in parallel. Okay, what is my V out? Okay, any answer? Connected to ground. So what is the logic if the two transistors are connected in parallel? For example, two switch. Okay, this is A and B. Okay, this two is connected. This is your input and this is your output. Okay, so if the A and B, A and B, if any one of the input is one, means what happens? The input will flow through the, flow through this one, and it will reach the output, right? So if any one of the input is 1, output becomes 1, right? So what is this logic? What is this gate actually? OR gate, right? So this is OR gate, right? Okay, this is OR gate. So here my output is NOR gate. Okay, output is NOR. So inverse of this one is this is actually a OR gate. So you will get the inverse of the this logic. Okay, so R oda inverse on the NOR. So option is NOR. So if the input frequency and the output frequency for the cascade counters below are respectively 30.72 megahertz and 1 kilohertz, then the Johnson counters has dash number of bits. Okay. So usually the output frequency is less than the input frequency. Okay. So in the decade counters na enna appdin paathitingna, decade counter is nothing but decade na 10 nu artham. சரியா, it has 10 states nu artham. State na ஒன்றும் இல்லை. இப்போ suppose 0 0 0 0 0 0 0 1 and 1 0 1 1 இருக்குன்னா இப்போ டோட்டல் ஸ்டேட் எவ்வளவு? டோட்டல் ஸ்டேட்டஸ் 4 இல்லையா? ஸோ இது வந்து மாட் 4 அப்படின்னு சொல்லலாம். சரியா, டோட்டல் ஸ்டேட். ஸோ அதே மாதிரி டிகேட் கவுண்டர்ஸ் அப்படின்னா இட் வில் கவுண்ட் ஃப்ரம் 0 to 9 இல்லையா? ஸோ டோட்டலாக 10 ஸ்டேட் இருக்குன்னு அர்த்தம். ஸோ வாட் இஸ் F1? F1 is always less than input frequency இல்லையா? ஸோ திஸ் இஸ் F1. ஸோ இந்த F1 வந்து it is nothing but is equal to Fin by 10. Correct? So next F2. So what is F2? F2 is obviously F1 divided by 6-bit triple counter. Okay. So what is 6-bit triple counter? In 6-bit triple counter, I have 2 power 6 states, right? If I have 2 bits means, if I have 2 bits A and B, 2 bit means 2 bits means I have 4 state, right? 2 power 2. Yeah. So if I have 6 bits means I require this is ripple counter, so it is nothing but a asynchronous counter. Okay, so you require 2 power 6 bits. Next F3. What is F3? F3 is nothing but a Johnson counter. Okay, so suppose what is Johnson counter means, if I have two D flip-flops, okay, 2 or 3 bit D flip-flops, okay, 2 or 3 D flip-flops, Okay, here then the Q bar is connected to input of the first flip flop. Okay. This is how. So this is your Johnson counter. Okay. So suppose my first input is 0 0. Okay. First output is 0 0. First output is 0 0. In the next state, this 0 becomes 1 here. So in the next state, it is nothing but 1 1, and this 0 goes to the second output, right? Because D means what are the input that is going to the output in the next state. சரியா? ஸோ அப்போ இந்த 0வும் 0வும் என்ன ஆயிரும், இங்கே போயிடும். 0 0 இல்லையா? அப்போ என்ன இருக்குது அப்படின்னு பார்த்துட்டிங்கன்னா, இதோட இன்வர்ஸ் வந்து இங்கே வருது. இதை ஏபி, இதை வந்து எப்படி எடுத்துக்கலாம், ஏபிசின்னு எடுத்துக்கலாமே. ஏபிசின்னு எடுத்துட்டீங்க அப்படின்னா ஏபிசி. ஸோ ஏல இனிஷியலாக 0 0 இருக்குது. ஸோ நெக்ஸ்ட் ஸ்டேட்டில் வந்து என்ன ஆயிடுது, இதோட இன்வர்ஸ் வந்து இந்த இடத்துல வந்தது. சியோட இன்வர்ஸ் வந்து ஏக்கு வருது. ஏபி வந்து இட் இஸ் கோயிங் டு பிஎன்சி. சரியா? ஸோ நெக்ஸ்ட் ஸ்டேட் என்ன வரும், நெக்ஸ்ட் ஸ்டேட்டில் 1 1 0, ரைட்டா? ஸோ இதோட இன்வர்ஸ் 1 1 1. ஸோ இதோட இன்வர்ஸ் நெக்ஸ்ட்டு 0 1 1, நெக்ஸ்ட்டு 0 0 1, நெக்ஸ்ட்டு 0 0 0. ஓகேவா? ஸோ இதுக்கப்புறம் என்ன ஆகும், இதுக்கப்புறம் இட் வில் ரிப்பீட் த ஸ்டேட் இல்லையா? இந்த திருப்பியும் என்ன வரும், 1 0 0 அப்படி தான் இதாகும். ஸோ அப்போ டோட்டலாக எவ்வளோ ஸ்டேட் வருது, 1 2 3 4 5 6 இல்லையா? ஸோ அப்போது 3 பிட் இருந்துச்சுன்னா டோட்டல் நம்பர் ஆஃப் ஸ்டேட்டஸ், டோட்டல் ஸ்டேட்டஸ் 6 இல்லையா? ஸோ அதனால் என்ன பண்ணுறேன் அப்படின்னா, F3 is nothing but F2 divided by 2 into X. ஓகேவா? ஸோ X is nothing but number of bits. சரியா? இங்கே எவ்வளோ நம்பர் ஆஃப் பிட்ஸ், அதாவது 3 பிட் ஜான்சன் கவுண்டர், 4 பிட் ஜான்சன் கவுண்டர் அப்போ இந்த மாதிரிலாம் சொல்லலை. சரியா? ஸோ அதனால் நான் என்ன பண்ணிக்கிறேன், அந்த பிட்டை வந்து எக்ஸ்ன்னு எடுத்துக்கிறேன். ஓகேவா? ஸோ F0. What is F0? F0 is equal to F3 divide by என்ன பண்ணும், total number of states எவ்வளோ இருக்கு, in mod 8 counter how many states are there? In mod 8 counters, the name itself 8. Okay, so what is they have given, the input frequency they have given 30.72 megahertz, and input frequency output frequency is 1 kilohertz. Okay, so this is nothing but 1 kilohertz, right? This is 1 kilohertz. So what is F3 now? F3 is, I'm going to substitute this 2 in 1. Okay, 2 in 1. So if I substitute, I will get F2 divided by 16x, that is equal to 1 kilohertz, right? So what is F2 now? F2 is F1 divided by 2 power 6 into 16x. Okay. So what is F1? F1 is nothing but Fin divided by 2 power 16 into 16x into 10. Right? So what is Fin? Fin is nothing but 30.72 megahertz divided by 2 power 16 into 160x. Okay. So if I solve this one, I will get the value of x, right? So the x value is nothing but 3. X is equal to 3. So reduce the expression nor XOR NAND. Answer nor XOR NAND. So what is A XOR B? A XOR B is equal to AB bar plus A bar B, right? So instead of A, they are given NOR gate. So instead of B, they are given NAND gate. Okay. So NOR XOR NAND. What's the answer? X naught. Okay. So let me try to solve this one. So this is a A plus B, the whole bar. It's my sorry. Okay. In class will do that. So XR A dot B, the whole bar. Okay. So this is nothing but A bar, B bar. Okay. So you apply this formula. Okay. Into A B whole bar plus A bar A plus B into B A bar plus B bar. Okay. So this I can rewrite it as A bar B bar into AB plus what is A into A? A into A is 0. A into A bar is 0. Okay. So this is 0 and this is A B bar plus B A bar plus 0. So what is A into A bar? This is 0. Okay. This is nothing but A B bar plus EA. So how come you are getting X not with B partially? So in another way, I can solve my input is 0 0 0 1 1 0 1 1. So if I perform NAND gate, that is 1 1 1 0. If I perform NOR gate, means this is 1 0 0 0. If I perform XNOR between these two gates, I will get 0 1 1 0. So 0 1 1 0 is nothing but XOR gate. Next, mod 16 down counter. Initial state is 0 1 1 0. What will be the state after 37 clock pulse? So what is the initial state? Initial state is nothing but 0 1 1 0. Yeah. So the decimal count of this number is 6. Right? So in the first clock cycle எங்க move ஆகும்? Is that 6க்கு அப்புறம் என்ன வரும்? Is a down counter இல்லையா? எங்க போகும்? 5க்கு போகும் இல்லையா? First clock pulseல 5க்கு போகும். Second clock pulseல 4 இல்லையா? Third clock pulse 3. Second clock pulse, sorry, fourth clock pulse going to 2. Yeah. Next, fifth clock pulse 1. Sixth clock pulse to 0. Next, seventh clock pulse to 15. Yeah. Eighth clock pulse to 14. Ninth to 13. Tenth to 12. In 11th clock pulse to 11. 12th clock pulse to 10. In 13th clock pulse to 9. 14th clock pulse to 8. 15th clock pulse to 7. So how many states are there totally? It should have only 16 states, right? 16 states. எவ்வளோ ஸ்டேட்ஸ் இருக்கு இப்போ? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So டோட்டலாக 16 ஸ்டேட்ஸ் வந்துருச்சு சரியா. ஸோ இப்போ 16th கிளாக் பல்ஸ் அப்ளை பண்ணும்போது எங்கே போயிருக்கோம், எங்கே போகும், ஸோ 16 கிளாக் பல்ஸ் அப்ளை பண்ணும்போது ஏன்னா டோட்டலாக 16 ஸ்டேட்ஸ் தான் இருக்குங்க சரியா. 16 ஸ்டேட்ஸ் கம்ப்ளீட் ஆனதுக்கப்புறம் will again move to the initial state. Initial state என்ன, initial state is nothing but 6 இல்லையா. அடுத்தது 17th கிளாக் பல்ஸில் எங்கே போகும், 17th கிளாக் பல்ஸில் 5, 18th கிளாக் பல்ஸில் 4 இல்லையா, 18th கிளாக் பல்ஸில் 4, 19th கிளாக் பல்ஸில் 3 yeah, it get repeated yeah. So அப்போ 16th கிளாக் பல்ஸில் 6 அப்படின்னா 32 கிளாக் பல்ஸில் எங்கே போயிருக்கோம், 6ல் தான் இருக்கும் இல்லையா. 32 கிளாக் பல்ஸ்லையும் 6ல் தான் இருக்கும். ஸோ இப்போ this is 32 கிளாக் பல்ஸ் அப்படின்னா 32nd கிளாக் பல்ஸ் அப்படின்னா this is 33, 34, 35, 36 and 37 yeah. So 37th கிளாக் பல்ஸில் என்ன ஷோ பண்ணுது, showing 1. So 1 is nothing but 0, 0, 0. Any doubt? So what is the 16th complement of, what is the 16th complement of AB? Answer. So what is 15, 16 complement is 15 plus 1. So you have to take the 15th complement of this number, then you have to add 1 with that number. Yeah. So 15 is nothing but, how to represent 15 in binary means triple one, for 4 ones. Okay. So AB is nothing but A value is 10. Okay. This is represented in the hexadecimal number. How to represent the A in binary means 1, 0, 1, 0. This is 8 plus 2. Okay. This is 10 and B is 11. 8 plus 2 plus 1. This is 8 plus 2. Plus 2 plus 8 plus 2. Okay. And this is 1, 0, 1, 1. So I have to subtract it by 15, right? So if I subtract it by 15, means answer is 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 0, 1 0 1 0. Okay, so this is my answer. This is our 15th complement. Okay, 15th complement. Then you have to add 1 with this number. If I add 1 with this number means I get this. This is nothing but complement. Okay, 16th complement. So now if you convert this one into a hexadecimal number means this is hexadecimal number means this is 5, this is 4, 5, this is 5. Option is your answer. A 4-bit synchronous counter uses a flip-flop with a propagation delay of 25 nanoseconds each, the maximum possible time required for change of the state. Since it is a synchronous counter, the propagation delay is same for any number of flip-flops connected. ஓகேவா, எவ்வளோ ஃப்ளிப்-ஃப்ளாப்பாக இருந்தாலும் சரி எல்லாத்துக்குமே வந்து 25 நானோசெகண்ட்ஸ் தான் வந்து டிலேவாக இருக்கும். So the maximum possible time required for the change of status 25 nanoseconds. Yeah. Next 11th problem. So for implementing D flip-flop using RS flip-flop, what is the extra component needed? So we need to convert this RS flip-flop to, okay, so D Q bar RS. Okay, this is 0 0 0 1 1 0 1 1. D value 0 1 0 1. So in JK flip-flop, S is nothing but 0 0 1 XX. So formula, okay, XX 1 0. It's your formula. So if I plot a K-map for R means, so I have to consider only D and Q. Okay, so D and Q means it's a 2-bit number. D and Q 0 1 0 1. So for 0 0 it is X, then for 1 0 it is X, then for 0 1 it is 1, then for 1 1 it is 0. Okay, so I can group this one. So what's the answer? R is equal to D bar. Okay. So similarly for came up for S. If a plot came up for S means DQ 0 1 0 1. Okay, for 0 0 it is 0, for 1 0 it is 1, then this 2 is x x. I can do this one. So answer is S is equal to D, right? So now my RS flip flop, right? Yes, flip flop Q bar. So what is R? R is nothing but D bar, right? D bar. R is equal to D bar. Then S is equal to D. Block. So now, if I consider this area, okay, this becomes nothing but your D flip flop. Okay. So now tell me what is for implementing a D flip flop using R flip flop, what is the extra component needed? Not keep. Next 12th problem. The propagation delay of each flip flop is highly limiting factor in the design of. Okay. So if you consider ring counter, Johnson counter, and mod n counter, both are all are synchronous counter. Okay. The different one is ripple counter. This is asynchronous counter. So answer is asynchronous counter. So let me come to this fifth problem. It is 13th problem. Okay. So what is the minimum number of two input NAND gate which is used to realize AB bar plus CD bar plus EF bar? First, let me draw this one. Okay. A B bar, then C D bar, then E F bar. So any answer? So if you consider instead of this one, you can draw like this, right? to NOT gate. Because here also I can draw to NOT gate. So this becomes one NAND gate, and this becomes one NAND gate, and this becomes one NAND gate. Okay. So similarly, I draw for this area. I draw like this. Then okay. So tell me how many NAND gates are required. 1, 2, 3, and then 4. This is 5. Okay. 5 NAND gate, and this NOT gate also I can um, read or like this. Okay. This is 0 and 1. If it is 1 means this is 0. So if I, this is similar to NOT gate. Okay. NAND I can convert NOT gate by connecting both the terminal to the same terminal. Both the connected are short, both the inputs are shorted means it becomes a NOT gate. Okay. So how many NOT gates are required? 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally 9 is required. Okay. So or if I want to still minimize this one, I can draw it like this. But they have asked only um, two input NAND gate, right? So two input NAND gate means answer is 9 only. If they have asked about the minimum number of NAND gate means I can replace it as answer is 8. Okay, but they have asked only two input NAND gate, so option is 9. Answer is 9. 2, 3, 4, 5, then 6, 7, 8, 9. Okay, 14th problem. So can anyone tell the answer for this one? This is AB. Okay. So what is the formula? F that is equal to F is equal to, if S1 and S not is 0 0 means I naught will get selected, right? So S1 S bar is 0 0 means I not get selected. If S1 bar S not, that is 0 1. Yeah, 0 1 means I1 gets selected. Then if it is S1 S not means I2 gets selected. In S1 S not means I3 gets selected. Okay. So now what is S naught? S1 S naught? S1 S naught is A bar B bar. What is I naught? I naught is C. I naught is connected to C. Then A bar B C plus A B bar C bar plus A B C bar. So how to minimize this equation? So I can take A bar C common. A bar C common in this one. So answer is B bar plus B plus here I can take A C bar common. So this is B bar plus B. Okay. So B plus B bar is equal to 1. Why it is 1? Suppose B is 0, B bar is 1. So 0 plus OR gate is 0. OR of 1 is 1. B is 1, B bar is 0, is 1. So nothing but A bar C plus A C bar. Missed this one. The problem. So my option is equal to A bar C plus A bar C. This is nothing but A XOR C. Pink problem. So this is nothing but A bar, right? And this is A B the whole bar, and this is B C whole bar. This is C bar. So finally, what is y? Y is equal to A bar plus C bar plus AB bar plus BC bar. Let's see, can we able to minimize this one? A bar plus C bar plus A bar plus B bar plus B bar plus C bar, right? Because AB the whole bar is equal to A bar plus B bar. D Morgan star. So this 2 get cancelled out because A plus A is equal to A. So C bar plus C bar is C. Then A bar plus A bar is A. B bar plus B bar is B. So option is A bar plus B bar plus C bar. So this I can write it as A, B, C the whole bar. Okay. So all the options are correct. Option D, all the above. So 16th problem answer. Answer for 16th problem. So C is your answer because A bar is equal to 0. Likewise, B bar is equal to 0. So your final answer is AB plus A bar B bar. Okay. 17th problem. The output of the logic gate is 1 when all the inputs at the logic is 0. Then the gate is answer. 17th problem answer. All the inputs are 1, but I am getting output as 1. So 1 is Answer. This is not OR gate, right? And also NAND gate also won't get. NAND or not. So both will come. NAND and NOR both will come, right? So XOR or XNOR. XOR will come or XNOR will come. XOR, right? Because so you must have an even number of odd number of ones. Okay, you must have odd number of ones. Okay, for example, if my input is ABC, okay, ABC, uh, my logic is 101. Okay, so here the number of one is odd, yeah, so even. Number of one is even. ரெண்டு ஒன் இருக்கு சரியா. ஸோ அப்போ மை அவுட்புட் எப்படி இருக்கணும், ஆடாக இருக்கணும் இல்லையா, ஃபார் எக்ஸ்ஆர் கேட். ஸோ இது ஆடாக இருக்கணும்னா அவுட்புட் பிகம்ஸ் ஒன் இல்லையா. ஸோ இப்போ மொத்தமாக எவ்வளோ ஒன் இருக்குது, 3 ஒன்ஸ் இருக்குது. 3 இஸ் நத்திங் பட் அ ஆட். ஸோ இந்த மாதிரி கண்டிஷன் தான் இருக்கும். ஸோ இப்போ இங்கே என்ன கொடுத்துருக்காங்கன்னா எல்லாமே வந்து 0 இல்லையா. ஸோ இங்கே ஆட் நம்பர் ஆஃப் ஒன்னா ஈவன் நம்பர் ஆஃப் ஒன்னா. ஸோ இப்போ இங்கே நான் ஒன்னு போட்டேன்னா இஸ் பிகம்ஸ் ஆட் நம்பர் ஆஃப் ஒன் இல்லையா. ஸோ என்னோடய இன்புட் எல்லாம் 0 இருக்கும்போது அவுட்புட் வந்து 1. ஸோ அது வந்து எக்ஸ் நார் கேட். ஸோ ஃபார் dynamic RAM consists of one transistor and one capacitor. Okay, 19th problem. The output of the circuit shown in the figure is equal to. Answer பண்ணுங்க. That's the logic of XNOR gate. A bar, B bar plus AB, right? So here they are given A XNOR B bar. So what's the answer now? A bar B plus A B bar, right? Then here also the same. So XOR, then XNOR, yeah, XOR XOR. XOR XNOR XOR. So what is A XNOR A? A bar plus A into A. So this is nothing but A bar plus A. So what is A bar plus A? This one. So my answer is 1. Because A dot A is equal to A, right? A bar dot A bar is equal to A bar. So A plus A bar is equal to 1. Okay, 20th problem. So what is the output of the logic gate? Answer. So what is A XOR B? A XOR B. A XOR B is equal to A bar B bar plus AB. So here instead of B, they are giving us a 0. Yeah, ground na 0. So இப்போ சால்வ் பண்ணிங்கன்னா A bar 1 into 1, A bar into 1 plus A into 0. So this A bar. Okay. Next problem 21. So this is the output. Okay. So I already told if the two transistors are in parallel means it's a OR gate. இல்லையா parallel இருந்துச்சுன்னா OR gate add பண்ணணும். இல்லையா ஸோ சீரீஸாக இருந்துச்சு அப்படின்னா you have to multiply. Yeah. ஸோ இது எப்படி இருக்குது டிஎன்டி டிஎன்டி இஸ் இன் parallel சீரியஸ் இல்லையா ஸோ டிஎன்டி இஸ் இன் சீரியஸ்னால டிஇ மல்டிப்ளை பண்ணிக்கலாம் அதே மாதிரி BNC is in parallel. So B plus C. Okay. So B plus C is in series with A. Yeah. B plus C is in series with A. Okay. Now this DE and A into B plus C is in parallel. Yeah. So okay. So this is nothing but the whole bar of this one is nothing but your F. So inverse of this logic is nothing but your F. What's the answer? A into BC plus D. So answer is C. Extent 22. So which is a reduced form of expansion of this one. Okay. This is a reduced form. We are asking about the expansion of this one. What's the answer? So it's nothing but your distributive law இல்லையா, x plus y z அப்படின்னு சொன்னா, so x plus y into x plus z. ஸோ இது என்ன ஃபார்மில் இருக்குன்னு பார்த்தீங்கன்னா இந்த ஃபார்மில் இருக்குது. ஆன்சர். நெக்ஸ்ட்டு duality. So what is duality? Duality means plus வந்து how to convert into multiplication, vice versa. அதே மாதிரி 0 வந்து how to convert into 1. ஓகேவா? ஆன்சர் சொல்லுங்க பார்க்கலாம். ABCD. பப்ளிஷ் டெண்டர் கொடுத்துருக்கோம் இல்லையா, அப்போ ஒரு ஃபார்ம் இருக்கும். ஸோ ஹியர் ஏ டாட் பி இல்லையா. ஸோ ஏ டாட் பின்னா என்ன பண்ணும், ஏ ப்ளஸ் பின்னு மாற்றிக்கணும் இல்லையா, ஏ ப்ளஸ் பின்னு மாற்றிக்கணும். ஏ டாட் பி இங்கே ப்ளஸ் இருக்குது, ஸோ அதனால் டாட். அதே மாதிரி ஏ பார் டாட் சி, ஸோ அதை வந்து ப்ளஸ் மாற்றிக்கணும். அதே மாதிரி ப்ளஸ்ன்னு இருக்கிறத டாட் மாற்றிக்கணும். பி ப்ளஸ் சி இஸ் ஈக்குவல் டு ஏ ப்ளஸ் பி into a bar plus c. So option A. Okay. So here suppose my input is 0 0. Here this is 1. Here is this question and in the next class 24. Okay. So 24 this year came up. They are asking about number of essential prime implicants. Yeah. So essential prime implicant is, this is the first one. Okay. So your first one, and this is your second one. Okay. This is your third one. This is your fourth one. Yeah. The total of 4 essential prime implicants. Suppose if the question is like this, okay. Zero, 1, 1, 0, 0, 0, 0, 0, 0. So how many essential prime implicants are there? Answer. So this is the one. That's 2. It's 3. This is 4. So here also 4 essential prime implicants. So tell the answer for this one. 5. I already told you this is A plus A bar into A plus B. So it's equal to 1. So my y is A plus B. 26. Minimized form of this one. A bar B bar C bar plus A bar B C bar plus. Minimized form answer. So how to do is on observing we are having only 3 variables, right? A B C. So 3 variables means totally A B C C A bar A 0 0 0 1 1 1 1 0 B C. So this is A bar, B bar, C bar. So this is 1. And A bar, that is B, C bar, B, C bar, right? B, C bar. Okay. This is A bar, B, C bar. Next, A bar, B, C. A bar, B, C. Then A, B, A, B, C bar. A, B, C bar. Okay. So if I minimize this one, we get this one. If I group this one, I'll get a bar, a bar, a bar, a bar, c bar, right? A bar, c bar. Next, if I group these two values, I get b, c bar. If I group these two values once, I'll get a bar, b. The answer is a bar, c bar, b, c bar, a bar, b. So what is expression 27? Half adder. For half adder, what is your borrow and what is your carry? Sorry, what is your difference? D is your difference and X is your borrow. Answer? AB. AB. For AB, what are the possible values is 0, 0, 1, 0, 1, 1, 0 and 1, 1, right? So what is 0 minus 0? 0 minus 0 is 0, right? This is your difference. பாரோ எடுத்துருக்குமா பாரோ எடுத்துமான்னு பார்த்தா இல்லை இல்லையா பாரோ எதுவுமே வாங்கலை ஸோ பாரோ இஸ் 0. Okay, so what is 0 minus 1? What is 0 minus 1? 0 minus 1 is minus 1. So minus 1 represent borrow is 1. Okay, borrow is 1, difference is 1. Okay. What is 1 minus 0? 1 minus 0 is 1 minus 0 is 1. Okay. So here borrow is 0 and the difference is 1. What is 1 minus 1? 1 minus 1 is difference is 0, borrow is also 0. Okay. So this is nothing but your XOR gate. Yeah. This is XOR gate. இதோட லாஜிக் வந்து என்னது a bar b. Yeah. The answer C. Because XOR gate, this is A XOR B. Yeah. Okay, 28. So here the XOR gate is connected. 20 XOR gate connect பண்ணிருக்காங்க சரியா 20 XOR gate connect பண்ணிருக்காங்க ஃபஸ்ட்டு XOR கேட்டில் இன்புட் வந்து ஒன்றுக்கு 1 கொடுத்துருக்காங்க இன்னொன்று எக்ஸ் கொடுத்துருக்காங்க 20th XOR கேட்டோட அவுட்புட் என்னன்னு கேட்குறாங்க இது ஃபஸ்ட் XOR கேட் இது செகண்டு இது 20th XOR கேட் இதோட அவுட்புட் என்னன்னு கேட்குறாங்க Answer? what's the first XOR gate ஓட அவுட்புட் என்ன வரும்? 1 XOR இதுன்னா 1 X bar plus 1 bar X இல்லையா? So this is nothing but your X bar. So first XOR gate ஓட அவுட்புட் வந்து X bar சரியா? X bar X NOR X. ஸோ இது போட்டிங்கன்னா X bar வரும் ப்ளஸ் X வரும். That is equal to 1 இல்லையா? ஸோ நெக்ஸ்ட்டு வந்து அது என்ன ஆகும்? ரிப்பீட்டடாக தான் இருக்கும். ஸோ ஃபஸ்ட்டு அவுட்புட் 1 வருது, ஃபஸ்ட் XOR கேட்டு. செகண்ட் இது வந்து 2 வருது. தேர்ட் இதுக்கும் இது எக்ஸ் பார் வருது. ஃபோர்த் இதுக்கு 1 வருது இல்லையா? ஸோ அப்போ ஈவன் நம்பரில் வர அவுட்புட்டுக்கு வந்து 1 தான் ஆன்சர் வருது. ஸோ ஆன்சர் வந்து 1. Next 29. So what's the answer? ABC is your input, F is your output. சரியா? என்ன ஆன்சர் வரும்? F1 இங்கே இருக்குது, A bar B C இல்லையா? ப்ளஸ் for this one A B C bar இல்லையா? ஸோ நம்ம எப்படி எழுதலாம்? B காமன் எடுக்கலாம். B காமன் எடுத்தால் A bar C ப்ளஸ் A C bar இல்லையா? ஸோ இதை வந்து டியூவாலிட்டி பிரின்சிபல் அப்ளை பண்ணலாம் இல்லையா இதுக்கு? ஸோ டியூவாலிட்டி பிரின்சிபல் அப்ளை பண்ணிங்கன்னா A bar ப்ளஸ் C இன்ட்டு A ப்ளஸ் C bar. Option D. You can check this one, okay? So for 0 for 0 1 1 1, okay? So this is 1. E into A bar plus A into if I solve this one for 0 1 1, okay, A B C, this one is 1 and this is 1, this is also 0. So B is not your answer. So you can directly substitute and you can find the answer, right? B and C is 1. Okay. Okay. B, C, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So this is 0, 0, 0. Because for 0, 1, 0 is 0. Okay. 1, so 0, 0, 1, 0. So now you have to group. So if I group this one, I will get answer as B bar, right? And this 2 I can group. If I group this one, I will get A bar, C bar. And if I group this 2 value, I will get A, C. Yeah. So from this, I can write F is equal to B bar whole bar into AC the whole bar into A bar C bar the whole bar. So this I can write as B into A bar plus C bar into A plus C. This is the answer. Option A. So I hope more question now. So 30th problem, last problem. So what is a decimal? 40. How to represent 43 in hexadecimal and BCD number system? Answer? Can anyone tell the answer? How to represent 43 in hexadecimal and BCD? So 1, 2, 4, 8, 16, 32. Okay, 64. So 2's power 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 5, 6. Okay. So this number is not exceeding 64. Okay, so 64 is 0. So 32 plus 16 is 48. So giving 0 because it is more than 43. Okay, 32 plus 8 is 40. Okay, 40 plus 4 is 44. So I am giving 0. So 40 plus 2 is 42. 42 plus 1 is 43. Okay, so now this is your binary number, right? This is a binary number. Now you have to convert that one into a hexadecimal number. So from binary number, if you separate it by a 4 bits, means it becomes hexadecimal number. So what is this number? This is 8 plus 2 plus 1. 8 plus 2 plus 1 is 11. 11 is nothing but B. Okay. So this is 8 plus 4 plus 2 plus 1. So it is 2. Okay. So option is 2B. So what does BCD means? BCD is a binary coded number. Okay. Binary coded decimal. So 43 is my decimal number. So I have to represent each bit by a binary number. Okay. So how to represent 3 in binary? How to represent 3 in binary means 0, 1, 1, 0. 0, double 1. So usually the binary coded number is represented in a 4-bit number. சரியா? So 4-bitல 43 represent பண்ண முடியாது. 4-bitல represent பண்ண முடியாதுங்கிறதுனால என்ன பண்ணுறோம் அப்படின்னா 3 வந்து 0, 0, 1, 1 represent பண்ணுறோம். Because 2 plus 1 is 3. Okay. So how to represent 4 in BCD? 0, 1, 0. Right? So option is B. Suppose can represent any number in PC, right? Last problem, 31. Well, answer. So C, B bar, because B is 0, this will get selected, and if B is 1, C bar gets selected. Okay. The whole bar of this one, X gets selected. Pasting is get pasted. So if C B bar plus B C bar, A gets selected. Okay, this is your F. So if I know the value of X means I can solve. Okay. So I hope you have understood something is relevant to the digital electronics. What and all I have discussed is mod counters. Okay, mod counters, JK flip-flops, recording JK flip-flops, then few columns in number systems, right? Concentrated morely on the sequential circuits. So then how to convert the flip-flops, that is D to SR and SR to D, right? Then static logic also I have discussed, right? If the two transistors are connected in parallel means there is OR gate, and the output is inversion of that logic. Okay. Then I have also discussed the Johnson ripple, then the ring counters, and not counters. Then complement also I have discussed, right? 16th complement, 15th complement, how to perform. Then synchronous counters. Then few problems on how to reduce expression using a Boolean theorem. So I hope the session is useful for you. So if you have any doubt, you can text me in WhatsApp. So we will discuss the rest of the portion there. So thank you for your patient listening. Thank you. And if you have any doubts or if you have any suggestion, you can tell. Otherwise, you can leave. Thank you. Bye.